Okay, so at destructive plate boundary, this is where we've got two plates coming towards each other. And we've got one oceanic plate and one continental plate. And as these two plates come towards each other, one of them goes down underneath the other one. Which of the plates, oceanic or continental, do you think is likely to go down? That's right, it's the oceanic plate that goes down underneath the continental plate. And that's because the oceanic plate is more dense, so it's heavier than the continental plate. But it's always the oceanic plate that goes underneath the continental plate. Now we call this process subduction. That oceanic plate has been forced down into the mantle. So if we take a section of crust and force it down into the molten mantle, what do you think is going to happen to that crust? That's right, it's going to melt. And this is what we call the subduction zone here. This is where that plate being forced down into the mantle is essentially melting. And as that plate melts, it creates excess magma underneath the ground. And that magma will build up pressure beneath the ground as it increases. And eventually, that magma will explode out as an explosive volcano. And these volcanoes at a destructive plate boundary are called composite volcanoes. They're much more traditional volcano shape, the triangle shape that we associate with volcanoes. And they're made up of alternating layers of lava and ash. Now the lava here is different to a constructive plate boundary. It's much thicker. We use the word viscous. The lava is very viscous, so it doesn't flow very far before it solidifies, which is why the base of the volcano is much narrower in this instant. And as I've said, because this is magma forcing its way out, these volcanoes can be very explosive.